think I'm audible right now. I think I'm audible. My YouTube channel must be streaming me. Let me check. Let's just see. YouTube. Oh, I'm a dumbass. Blaze is OP. This is my channel. This is what used to be my channel. Let me switch my account. Blaze is OP. Yes, this is it. If I go to my Blazes OP33 to add Blazes OP332, this is it. This is me. Okay, I'm live. Let's let me just decrease the range. I think this will do it. This will do. Let's see. I hope so. Add Blazes OP332. This used to be my channel when I was a kid. I used to stream YouTube. I think this will do it. This will do. Let's see. I hope so. I am not audible. Add Blazes OP332. This used to be my channel when I was a kid. I used to stream YouTube. I think this will do. Let's see. I hope so. I am not audible. Guys, am I audible? What am I speaking right now? Whatever I'm saying, am I audible? Am I audible enough? Let's see. ओके तो थोड़ा सा डिले आ रहा है गैस और ये जो आवाज़ आ रहा है बैकग्राउंड का है गैस ये मेरे फ़ैन का है आई थिंक इट्स माई फ़ैन लेट मी पुट ऑन माई माइक्रोफोन Hello, am I audible? I hope so. Hello, am I audible? I hope so. Okay, this is much better. This is much better. I guess I'm audible enough, but my voice is not so that clear because of the buffering in the back. Okay, this is much better. This is much better. I guess I'm audible enough, but my voice is not so that clear because of the buffering in the back. Okay, this is much better. This is much better. I guess I'm audible enough, but my voice is not so that clear because of the. But my voice is not so that clear because of the. But my voice is not so that clear because of the. Okay, so let's begin our first video of my proof of work. This is my build in public account. This is but my voice is not so that clear because of the. Yeah, but this is like my first video. Okay, so let's begin our first video of my proof of work. This is my build in public yes account. This is but my voice is not so that clear because of the. Yeah, but this is like my first video. Okay, so let's begin our first video of my proof of work. This is my build in public yes account. This is but my voice is not so that clear because of the. Oh fuck, I'm fucking it up. Wait, I'll just use my phone to do this because you know what happens when I like stream with the video on my stream. Whatever I repeat is gonna get repeated on the stream, and then whatever gets repeated again in the stream, and then the loops just goes on and on and on. So it fucks up my stream. So I'm just not gonna open my stream anymore. I'm just gonna check via my smartphone. Blazes OP332. This is my first video, and yeah, I'm pretty excited. I'm extremely excited. I'm extremely excited. Extremely excited. That's yeah. Let's go. Let's fucking go, man. Let's go. Let's fucking go. Let's fucking go. I like to hear my voice. You know, whenever I speak, whenever I stream, there's always an audio cue going in my headphones, so that I can hear my voice back, so I know whatever I speak is get conveyed to you guys properly. That's why you do what I do. You know, a lot of people used to follow me back in the days. My stream is working. Yes, I used to stream PUBG Mobile quite a bit. Oh my god, it's 6 years ago. Fuck. Okay. Let's solve our first LeetCode problem. Let's go. I'm just gonna mute it. I'm just gonna mute everything. If you want my developer involvement, I can make a video on it, but I gotta get to at least 1,000 subscribers. And when I get to 1,000 subscribers, I'll give you I'll give you everything. Let's solve our LeetCode problem. The problem I'm gonna solve is let's see, which problem am I gonna solve today? I had it written, I think it was 119, double duplicates if I'm not wrong. No, this is Pascal's triangle. No, not this one, not this one. Pascal's triangle, no, not this one. And it was 18, I guess? 18? No, 18 is also Pascal's triangle. Oh, this is crazy. 17. Contains duplicates, yes. It was 219, okay. So the question is, give an integer array nums and an integer k. So what we have here is, let's just visualize it first, okay? I'm gonna use Excalidraw. Excalidraw is fine. How do I, let me just, yeah, so this is what I wanted to do. Just gonna open new document, select. This is nice, this is fine. Okay, so we have an array of nums and integer k. Return true if there are two distinct indices I and j in the array such that number of I, nums I is equals to nums j, and abs 1 minus j is smaller than equals to k. I don't know what abs 1 minus j is, so let's find that out. I minus j okay, it's mod. Absolute difference between I and j is at most k. Okay. I guess I know it. Okay. So absolute difference between both the numbers is smaller than equals to k, and k is an integer given an array and an integer k. Return true if there are two indices. Okay, एक integer, तो इसका मतलब हम लोग, this means that we're given an array and an integer. Where's the fucking skeleton? Yeah. Okay, so we're given an array. We're given an array and a number k. There are two indices I and j. There are two indices. There are two indices I, j. हमारे पास दो indices है I, j, और यहाँ पे हमारे पास k है. तो ये जो I, j है, इनमें से इनका जो absolute difference होगा, यानी I minus j, और ये दोनों का दोनों होगा हमारा, मतलब ऐसे, इसका जो एब्सोल्यूट डिफरेंस होगा वो स्मॉलर देन इक्वल्स टू के होना चाहिए. अगर ये ऐसा हो रहा है तो इसका मतलब हमारा जो गिवन नंबर है और इन दोनों का जो डिफरेंस है इन दोनों का, वो इससे छोटा होना चाहिए. ये तो हमारा गिवन है. तो कोई भी नंबर हमें अगर दे देगा, लिमिट क्लोज दिस, ओके, तो कोई भी हमारा नंबर दे देगा. फॉर एग्जांपल, ओके, एग्जांपल से समझते हैं. अगर नंबर हमारा 1 2 3 1 दिया हुआ है और अगर के हमारा 3 दिया हुआ है, तो इसका आउटपुट ट्रू होना चाहिए. ये बोल रहा है. और ये दोनों जो होना चाहिए, देयर आर टू डिस्टिंक्ट इंडाइसेस. आई और जे दोनों अलग होना चाहिए, सेम नहीं हो सकता, और रिटर्न ट्रू करना है. कंटेन्स डुप्लीकेट. सो इसमें हमारा क्या है कि इसमें डिफरेंस है हमारा कि जो नंबर होना चाहिए आई पोजीशन पे जो नंबर, आई इंडेक्स पे जो नंबर होना चाहिए और जे इंडेक्स पे जो नंबर होना चाहिए, उनका एब्सोल्यूट डिफरेंस के से छोटा होना चाहिए. सबसे पहली बात, एब्सोल्यूट डिफरेंस के से छोटा होना चाहिए, और जो नंबर होना चाहिए उन दोनों इंडाइसेस पे, वो इक्वल होना चाहिए एक दूसरे के. यानी वो डुप्लीकेट भी होना चाहिए, दो डुप्लीकेट होना चाहिए, और उनका इंडाइसेस का एब्सोल्यूट डिफरेंस के होना चाहिए. दैट्स व्हाट वी नो, राइट? राइट। ओके, तो इसमें मैं क्या कर सकता हूँ, मेरा दिमाग जा रहा है इसमें एक फॉर लूप लगाने के लिए, क्योंकि पिछली बार हमने किया था डबल निकालने का एक तरीका है कि कंटेन्स डुप्लिकेट्स, ना फिर तो एन स्क्वायर हो जाएगा ना, उसका टाइम कॉम्प्लेक्सिटी बहुत ज़्यादा बढ़ जाएगा, एन टू द पावर एन हो जाएगा। नहीं नहीं, ऐसा नहीं कर सकते। ठीक है, कि अगर 2 दिया हुआ है तो यहाँ पे आउटपुट फॉल्स होना चाहिए। क्यों यहाँ पे फॉल्स होना चाहिए? क्योंकि सेम यहाँ पे कौन कौन है, 2 2 फॉल्स है। इसका इंडेक्सेस क्या है, 1 2 3 4, 1 और 4, 1 और 4 का डिफरेंस 2 है, तो 2 से इक्वल होना चाहिए। यहाँ पे तो आउटपुट ट्रू होना चाहिए ब्रो, यहाँ पे तो आउटपुट ट्रू होना चाहिए। व्हाट द फक इज दिस? 0 1 2 3, 0 और 1, इनका एब्सोल्यूट डिफरेंस 3 होगा, ये नहीं होगा। तो 1 2 1 2 3 4, 1 एंड 4, इनका एब्सोल्यूट, अच्छा डिफरेंस इसका 4 आ रहा है, इसका भी डिफरेंस 3 आ रहा है, तो 3 3 3 ये फॉल्स होगा, ये होना चाहिए। हमें ये तो समझ में आ गया, कंस्ट्रेंट्स हमारा होगा जो नंबर लेंथ है वो 10 to the power 10 से। ओके 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 ओके। सो सीन दिस क्वेश्चन इन रियल इंटरव्यू बिफोर? I don't know, I've never given an interview. Okay, so I actually have no idea how to solve this. I actually have no idea how to solve this. Now we're gonna go to 50-hour DSA lectures. Oh, this is YouTube Studio. My bad. I'm gonna go to YouTube. And then 50-hour DSA. Yeah, this is
Hello friends, hope you're having a fantastic.
If you want to prepare for your interview, this is a really good. This is extremely valuable resources. This is one of the most valuable.
And also a very well liked problem on LeetCode.
Yes.
Basically, we are given an integer array called nums, or we are going to denote it as n, that contains array values. We are also given a value k, and k can be anything like 1, 2, 3, 4, any single integer value. So suppose k is equal to 3. Now we need to return true if there are two possibilities. The first possibility is there exist any two values I and j that are exactly same. So if there exist two duplicate values in the array, and the second portion is that the difference between I and j. So I and j refers to the index positions of every single value inside the given array. So the index position should be actually less than the value of k. Let's try to understand this with few examples. So suppose our given input n is equal to 1, 2, 3, 1, 5. If this is the input we are given, and we are given the k value to be 4. If this is the case, does it satisfies these two properties? So first let's see. Okay, so we need to check that between the window 4 there needs to be two duplicate values. Currently we can see that there exists a duplicate value 1 and 1 over here. Let's see the index position 0 and 3. So if we do the difference 0 minus 3, so basically we need to do the absolute difference. So the answer is going to be 3. 3 is actually less than the value of 4, which means this one currently contains the duplicate value that is not far away from 4 elements from each other. So in this case we are going to return true. Let's try to understand it with one more example. Suppose our given n is equal to 1, 2, 3, 1, 0, something like this, and our given the of each check up until this point, that we suppose this is the input we are given. Now let's see the brute force way to solve this problem, that we pick any element, then we check the next k elements. So in this case currently we are allowed to check up until this point. So between these portions we check that whether 0 is present in any other value or not. If 0 is not present, we can define that 0 would not be a duplicated entry in any of the window, because we are strictly told that we can only check next three elements. So in this case we can get rid of 0 because 0 is not present. Same way we are going to check for value number 5. So currently value number 5 is located at index number 1, which means we have the ability to compare between these portions. So again for value number 5 we are going to check this value, and bingo, we find value number 5. So we can return true in this case because element number 5 exists and the difference is less than 3. But this is like a very inefficient approach. Why inefficient approach? Say for an example, this entry does not contain any duplicated values and all the values are unique, and at the same time what we would do is for every single element we would compare it with the next three elements, and we would keep on repeating the same process until we reach to the end of our loop, and that would be an inefficient approach because the time complexity would be big O of n. So n is the total number of elements multiplied by k, and this is not what we want. We want something more efficient. So let's see an more efficient and better approach. A better approach is that we know that for any single value we need to check in the remaining portion whether that value is present or not. So currently we can break it down in this sequence. So currently we can create a window like the 0 and then 5 2 7. Currently we are at this position number 0. Now we need to check that whether 0 exists in the remaining three entries or not. First approach is to do binary search. So for binary search what we would need to do is we would need to sort this given input, and if we sort this input array, the sorted result is going to look like the 0 2 5 and 7, and then all we need to do is check any two consecutive values. If we identify that there exists like a back-to-back entries that contains the same value, then we can return true. If it does not contain, then we can move on to the next window, and again in the same way we would repeat the same process for this next window that is currently comprised of the values 5 2 7 and 3. And again, okay, so let me fix this one. So this one should be 5 not 7 and 5 2 5 3. So again if we sort this window in this case, the answer we are going to get is 2 3 5 5, and we found two back-to-back values that contains the same value. So in this case we can return true. But the thing is, even this approach is also not very efficient because if we see time complexity in this case, the time complexity is going to be big O of n, then log of k. Why log of k? Because for any given input, we will actually have to sort this, and sorting it cost us a lot of time and energy. And this is better than the brute force approach, but still there can be improvements made. So what is one improvement we can make? And again, remember, we are using sliding window because we know that we need to do this in any subsequent values, and we need to find the answer. So definitely you understand by seeing the problem that why we need to use the sliding window. But let's see that what would be the improvement we can make. First thing we need to check is that in the binary search approach, what we had to do is we need to check that whether in the remaining portion does the same element exist or not. And also at the same time, we were considering that every single time we need to create a new window, we would have to do the entire sorting calculation again. So we need a data structure that can very quickly get rid of elements and add new elements, at the same time very quickly search that whether the existing element exists or not. And the wonderful answer for this this type of scenario is a hash map. So we can create like a hash map or a hash set inside our input, and hash map and hash set are wonderful at doing two things, like doing the search and remove an input are like that whether the existing element exists or not. And the wonderful answer for this type of scenario is a hash map. So we can create like a hash map or a hash set inside our input, and hash map and hash set are wonderful at doing two things, like doing the search and remove and input operations in big O of one time. So hashing is really good in that. Also at the same time, it does not allow duplicate entries, so no duplication is allowed, which means we can identify duplicate entries very quickly, very efficiently in any sort of hashing input. So we are going to use this property combined with sliding window approach to solve this problem in the most efficient manner. Let me quickly show. So first we are given the value of k, which means we are going to create our window. So currently let's just create a window of size k. Okay, so starting from value number 0 to value number 5, and then we will
Okay, मैं समझ गया इसको कैसे करना है. Let me copy this. They just came from me, I tell them no. I don't wanna leave my baby alone. I don't wanna leave her alone. It's the chance I take, baby, I say. हैश मैप हमने बनाया सबसे पहले, फिर उसके बाद हम एक फॉर लूप चला कर सारे एलिमेंट्स को हैश मैप के अंदर रखेंगे, राइट. इंट आई इज इक्वल्स टू 0 एंड देन आई शुड बी स्मॉलर दैन एरे. ओके, द एरे नेम इज नम्स डॉट लेंथ. यहाँ पे हमने सेट कर लिया ये, फिर ये इंक्रीमेंट होगा और ये हमारा बन जाएगा फॉर लूप, राइट. तो इस फॉर लूप में हम क्या करेंगे, एक एक करके पहले एलिमेंट्स को पुट करेंगे उस हैश मैप में. तो हैश मैप में पुट करेंगे हम लोग सबसे पहले. ऐसे होता था ना. I forgot. Oh, sorry. It was map dot put map dot put And what were we gonna put? We were gonna put the array name was nums, and the element should be I, and then we're gonna put every single thing until the array is complete. This is just a for loop to create a map, and then what I'm gonna do is I'm gonna check if there are any duplicates. ओके अगर कंटेन करता है तो हम रिटर्न कर देंगे दोनों का इंडाइसेस रिटर्न करेंगे ना दोनों का इंडाइसेस से ही हमको मतलब है तो हम रिटर्न कर देंगे क्या पहला वाला में हमको चाहिए आई और जे का चाहिए ना तो हमको आई तो प्रिंट करना ही है क्योंकि वो नम का वहाँ पे कंटेन करता है और फिर Okay. ओहो, नहीं समझ में आ रहा.
Will have all the values 0, 5, 2, and okay, let's in our hash map. At the same time, we can check that currently, since the value of k is equal to 3, we already added 4 elements, and still we were not able to find any duplicate entries, which means we will have to update our window. So in order to update our window, rather than getting rid of all the items, what we can do is we can just get rid of the first element, and then we can just shift our window to include one more entry inside our input, and that is going to be value number 5 for the index value position number 4. So again, we add 5 over here. At the same time, since we got rid of the first index value, we are going to also get rid of that inside our hash map. So we are going to get rid of the first entry, and currently we have 3 entries. Again, we will try to check that whether 5 exists or not. So we will try to input 5 inside our hash map, but we would be able to immediately find that 5 is already present as a value inside our hash map, and immediately we can return true saying that this contains duplicate inside a k window. And see, what we did is that initially our window was consisting of this value number 0. We got rid of the only 0th value. We kept the remaining values inside our window, and we simply added a new value inside our hash map. And then we were able to immediately identify that whether this is the correct response or not. And say, for example, if somehow this value is not value number 5, this is value number 11 or something else, this does not contain any duplicate entries, what would happen is that every single time we would get rid of the last element from our hash map, and we would keep on adding new values to our window, and eventually we would reach to the end of our input, and if we don't find any answer, we can simply return false in this case. So if we see time complexity in this scenario, the time complexity is actually going to be big O of n only, and since for this case we had to use a hash map of size k, the space complexity is going to be big O of k. But this is a very wonderful and beautiful approach to solve this problem. So that is why the sliding window technique is really powerful, because you are already building your solution upon the already calculated computed values. You are not doing everything from scratch, and that is very powerful in making your inputs more efficient. Okay, so for this problem, I'm not going to write the entire code. I'm just going to give you the explanation. So first we are going to initialize our hash set, and I mentioned that we can use hash map or hash set, anything. In this case we are using hash set. Now we are going to iterate over the given input array using a for loop. First thing we are going to do is to check that whether our set contains the current value, current ith position of value we are at. If that is the case, we can return true immediately. If that is not the case, we would add that entry to our hash set. At the same time, we would check that if the current size of hash set, if that is greater than our given input k, if that is the case, then we need to remove the earliest entry inside our hash map, and we can calculate that using the number of ith index than our hash set. At the same time, we would check that if the current size of hash set, if that is greater than our given input k, if that is the case, then we need to remove the earliest entry inside our hash map, and we can calculate that using the number of ith index that we are currently at minus the value k. And then if we remove that value from the hash, set. Our hash set is only going to contain only the k elements, and then we can keep on repeating the same process until the very end. If we haven't returned true by then, we can return false in the end, and this is going to be the whole solution. Let's try to run this code. Seems like our solution is working as expected. Let's submit this code, and our code runs decently efficiently compared to a lot of other solution. And I would be posting this in the comments so you can check it out from there. Thank you. And I
Okay. Okay, so I'm gonna end the live stream now.